All right, I'm going to work through this real quick because this is the third time I've tried to record. So in your book on page 621, we're going to look at these problems. So the heparin protocol is above. The client weighs 100 kilograms, so we don't have to convert that weight. Determine the bolus of heparin, the initial infusion rate, and then adjust the hourly infusion rate up or down based on APTT results using the above weight-based heparin protocol. So, the patient weighs 100 kilos. Determine the bolus dose of heparin. So, it tells us bolus heparin at 80 units per kg. So, we're going to multiply 80 units times 100 kilograms. So our bolus is going to be 8,000 units. And then it says the initial infusion rate we determine. Begin intravenous infusion rate of heparin at 18 units per kg per hour using 25,000 units of heparin in 250 mils of D5W. That's our concentration. But your book goes further and tells you it's 100 units per mil. I recommend using the 25,000 units per 250 mils because that's what you will be exposed to, okay? So we have 18 units times 100 kgs, and that's going to be 1,800 units per hour. That is our units per hour. Now, if we want to find the milliliters per hour, we have 1,800 units using dimensional analysis. Our concentration is 25,000 units per 250 mils. So we're going to multiply that across and then divide. So we have 1,800 times 250 equals 450,000 divided by 25,000. That's going to give us 18. So we have 18 milliliters per hour. So this is our units per hour, and 18 is our milliliters per hour. Then it tells us the APTT is reported as 71 seconds. This pump delivers milliliters per hour, whole milliliters per hour. So this is our maintenance rate, but our APTT is now 71 seconds. So we look at our protocol. 71 seconds, we are to decrease by 2 units per kg per hour. So to do that, we just simply multiply 2 units times 100 kgs, and that's going to give us 200 units per hour. So our rate is going to go from 1,800 units, and we're going to add, because we're increasing, by 200 units per hour. I'm sorry, it's 71, so we're decreasing. We're going to decrease by 200 units per hour. So now we have 1,600 units. And then if we want to find out how many milliliters per hour that is, we're just going to set up like this. And we're going to cross multiply. So our new rate is 16 milliliters per hour. So we'll do one more, and hopefully it'll record. So we have a client that weighs 162.8 pounds. And we're going to convert that to kilograms, which is going to be 74 kilograms. Okay? Determine the bolus dose, the initial infusion rate, and then adjust the hourly infusion rate up or down based on the APTT results. So, 74 kilos. The bolus is 80 units per kg. So, 80 units times 74 kgs. So our bolus is, 5,920 units per hour. And if we want to move on, our infusion rate is 18 units per kg per hour with our concentration of 25,000 units per 250. So 18 times 74 kgs for our initial infusion rate. It's going to be 1332 units per hour. So then we want to find our milliliters per hour based on our concentration of 25,000 units per 250 mils. So 1332 times 250 is 333,000. We're going to divide that by 25,000. And that gives us 1332 milliliters per hour. Okay. Then it tells us our APTT is 30 seconds, and this pump delivers in tenths of a mil. So 38 falls within this range right here, 35 to 45. So it tells us to rebolus with 40 units per kg. So we need to actually calculate that out and then increase the rate by 2 units per kg per hour. So rebolus with 40 units times 74 kgs. That's our bolus. 40 times 74. So that's going to be rebolus 2960 units. And our initial rate, our units per hour is here. That's our milliliters. So we're going to increase the rate by 2 units. So 2 units times 74 kgs is going to be equal to we're going to increase by 148 units. So we're going to take this right here, which is our initial rate, 1332, and we're going to add 148. Oops. That's going to give us 1480. So our units per hour is 1480. And if we want to find that hourly rate, this time I'm using ratio and proportion. And when you calculate that out, we're going to multiply 1480 times 250 and divide it by 25,000. 1480 times 250 divided by 2. That gives us 14.8 milliliters per hour. Okay. Hopefully that helps.